Hello, everyone, and welcome back to the Everyday English Bite. Thank you for joining us for another bite-sized explanation of the complex world of technology, designed to help you improve your English at the same time. In our first two episodes, we explored the basics of artificial intelligence, AI, and its fascinating history, from early visions to the incredible creations we use today, like chatbots. If you missed those, please go back and listen. They are the perfect starting point. Today, we are shifting focus to a critical, real-world problem in AI development and a recent breakthrough that aims to solve it. We will be discussing TurboQuant, a new AI memory compression technology announced by Google. It sounds like a lot of technical words, but by the end of this episode, you will understand exactly why it matters and how it could change the future of the devices you use every day. First, let's understand the problem. AI models are getting bigger and smarter, which is exciting, but there's a huge hidden cost. They require massive amounts of memory. Think of an AI model like a super intelligent human brain. To perform complex tasks, it needs to remember a lot of information. This information is stored in special computer memory chips, often called high bandwidth memory. Vocabulary check. Memory, noun. Memory is where a computer stores the data it needs to access quickly. Vocabulary check. Bandwidth, noun. Bandwidth is the speed or capacity at which data can be moved from one place to another. Here's the problem. The bigger the brain, the bigger the memory it needs. However, making memory bigger is expensive and technologically difficult. It's like having a very fast car, but the road it travels on, the memory bandwidth, is narrow and crowded. This creates a bottleneck, meaning the AI can't work at its full speed because it's waiting for data to travel. To keep AI advancing, we need a better way to move and store data. This is where Google's TurboQuant comes in. In simple terms, TurboQuant is AI memory compression. It makes the data that the AI needs to remember smaller. Think about packing for a vacation. If you have a massive, heavy suitcase, it's hard to move. AI memory is like that. TurboQuant is like using a compression bag to suck all the air out of your clothes. You can fit more clothes into the same sized suitcase, or use a smaller, lighter suitcase. TurboQuant uses a specific technique called quantization. Vocabulary check. Quantization, noun. Quantization is the process of reducing the number of bits needed to represent data, making it smaller by making it less precise, but still highly functional. Imagine a painter who has 100 different shades of blue. Symbolic, right? But the computer has to store a detailed mathematical description of each of those 100 blues. That's a lot of data. TurboQuant tells the computer, instead of 100 blues, let's just use 4 basic blues. It simplifies the data. Yes, you lose some detail, but the overall picture of the sky is still clear, and it takes up much less space. This simplified, less precise data is then compressed further to save even more memory. Why is this technology so important? Let's look at its 3 major pros or advantages. Pro number 1, saving money, cost reduction. Memory chips, especially high-speed ones for AI, are very expensive. By making the AI use less memory, companies can save millions of dollars in hardware costs. Pro number 2, faster performance. Imagine the crowded road from earlier. With TurboQuant, the data cars are now much smaller. More of them can fit on the narrow road and they can travel faster. This speeds up the whole AI process. Pro number 3, increasing accessibility. This is critical for you and me. Right now, to run a powerful AI model, you need a massive, expensive supercomputer. But if TurboQuant can make the AI brain small enough, we can run powerful AI right on our smartphones, laptops, and smart home devices. We won't always need a cloud connection, making AI faster and more private. It also makes AI a green technology by reducing the energy needed to power massive data centers. Of course, like the compressed suitcase that might wrinkle your shirts, TurboQuant is not perfect. Let's look at its major cons and challenges. Con number 1, data loss or lossiness. Remember our 100 blues simplified to 4 blues? By making the data less precise, the AI model might become slightly less accurate. If it's a translation AI, a simple word could be missed. Google has to carefully balance the compression with maintaining the AI's intelligence. Vocabulary check. Lossy, adjective, lossless, adjective. Lossy compression loses some data in the process, like a lower quality photo. Lossless compression loses no data, but the reduction is usually smaller. TurboQuant is mostly lossy. Con number 2. Increased complexity. To use compressed data, the computer has to first decompress it, which takes a little extra time and processing power. It's like having to unpack that airtight suitcase every time you want a new shirt. Con number 3. Limited compatibility. TurboQuant is a specific tool that doesn't work on every AI model. It requires developers to design their models with compression in mind. The field needs to improve compatibility. Vocabulary number 5. Compatibility. Noun. Compatibility means the ability of two things to work together without problems. Now, for the big question, will this make memory prices drop? The answer is complex. Let's look at the market in the short term versus the long term. In the short term, the initial impact on memory chip prices will be limited. It takes time for this technology to be adopted. However, by making AI use less memory, it might slightly slow down the immediate frantic demand for those expensive AI chips, which could lead to a small price reduction. In the long term, the effect could be more significant. Instead of needing 16 gigabytes of memory to run an AI, maybe you only need 4 gigabytes. This would make memory price efficiency much better. A manufacturer could sell a smartphone with great AI features without having to include a massive, expensive memory chip. So from a cost for performance perspective, it should make memory feel cheaper. However, as AI gets more popular, people will want more AI on more devices, so the overall demand for memory might still stay high. It's a battle between compression making things smaller and popular demand wanting more. Finally, related to this is the competition from new types of hardware, like special AI-specific chips that are naturally more efficient. This technology is a software-based solution, but it might one day be combined with new hardware to create even smaller, faster AI. And that, everyone, is our 10-minute bite on Google's TurboQuant. We traveled from the crowded roads of AI memory to a technology that can shrink an AI's brain. We learned that TurboQuant uses quantization to save money and make AI faster and more accessible, with the challenge of data loss and compatibility. It's a powerful example of how software innovation can solve major hardware problems. Remember today's keywords: memory, bandwidth, quantization, lossy, and compatibility. Thank you for listening to the Everyday English Bite. Please subscribe and leave a review. Keep practicing your English, and I will see you in the next episode for another Bite. Take care.